MS Ramaiah University of Applied Sciences.
Hello students, let us have a discussion on calibration of a pressure gauge using deadweight pressure gauge tester. This experiment aims at depicting the calibration of a pressure gauge using a deadweight pressure gauge tester. Calibration is necessary for verifying the correctness of a reading as obtained by a measuring instrument. It is the comparison between a known measurement, which is a standard, and the measurement as obtained by a measuring instrument. It is carried out for a new instrument, a repaired or a modified instrument, after the lapse of a specific time period, after a specific number of hours of usage of an instrument, and in other similar scenarios. A pressure gauge is an instrument that is used to measure the gauge pressure of a system. The gauge pressure is defined as the pressure which is acting on the system other than the atmospheric pressure. Figure 1 shows a dial type pressure gauge. This pressure gauge is graduated in kg per centimeter square. Its range is 0 to 28 kg per centimeter square and it has a least count of 0.5 kg per centimeter square. Figure 2 shows the deadweight pressure gauge tester and its parts. It comprises of a dial type pressure gauge, a connector to digital pressure gauge which is optional, a plunger, a valve to pressurize the plunger, a set of 7 dead weights, a valve to control the tank line pressure, and an inlet to fill the tank of the equipment with oil. The apparatus required for carrying out this experiment are a deadweight pressure gauge tester, a pressure gauge which is to be calibrated, and a set of dead weights which is the calibration standard. Here goes the procedure for carrying out this experiment. The initial reading on the pressure gauge should be 0 kg per centimeter square. For this, the tank line valve should be completely closed and the plunger valve should be completely open. A set of 7 dead weights are then placed one over the other upon the plunger. The bigger weights weigh 1.4 kg each and the smaller weights weigh 0.57 kg each. The weight of the plunger is 0.13 kg and hence the total weight acting on the system is 5.78 kg. After placing the dead weights one over the other, rotate the plunger valve clockwise such that pressure starts building on the plunger. As the pressure in the system reaches its maximum possible level, the plunger automatically lifts up. At this point, the pressure gauge reads close to 20 kg per centimeter square. Note down this reading in the tabular column. Now remove the topmost weight placed on the plunger. There will be a pressure drop observed in the pressure gauge. Note down this reading too in the tabular column. Similarly, remove the next weight on the plunger which will again result in a further drop in the pressure. Note down the reading in the tabular column. Repeat the above procedure until only the last weight is remaining on the plunger. Once you have noted down the pressure gauge reading for the last weight on the plunger, open the tank line valve completely such that the pressure inside the system becomes 0 and then remove the last weight from the plunger. Note that you should not remove the last weight from the plunger when the tank line valve is closed. Doing so will lead to oil spurting out of the system as the system is still under pressure. Now, using the valves of the weights and area of the plunger, calculate the actual pressure acting on the system for each of the weights that are removed from the plunger. Compare the calculated actual pressure and the measured pressure as obtained from the pressure gauge. Calculate the error between the actual pressure and measured pressure and plot the required graphs. The readings obtained must be tabulated in the format of a tabular column. Carry out the calculations using the standard formulae and find the percentage error in the pressure gauge reading. The diameter of the plunger is 0.6 centimeter. Using this, the area of the plunger can be calculated. Two graphs have to be plotted after tabulating the readings in the tabular column. Actual pressure reading versus measured pressure reading. Actual pressure reading versus percentage error. This experiment has its limitations. The calibration of weights cannot be ensured. Internal leakages might occur inside the system which are difficult to determine. These leakages may lead to drop in system pressure which leads to wrong readings. The readings cannot be taken accurately as the least count of the pressure gauge being used is 0.5 kg per centimeter square. This concludes the experiment calibration of a pressure gauge using dead weights pressure gauge tester.
Hello students, today we are going to conduct the experiment calibration of pressure gauge using dead weights. The aim of this experiment is to calibrate the pressure gauge using dead weights. Calibration is a process of comparing the value obtained by a measuring instrument with respect to a known standard. The apparatus of this experiment consists of a pressure gauge calibration setup which includes a plunger. The plunger is used to take the weight. An oil inlet. The oil inlet is used to fill the oil inside the setup. A pressure gauge. The pressure gauge measures the pressure being applied on the plunger. The least count of this pressure gauge is 0.5 kg per centimeter square. A valve which passes the pressure to the plunger. By rotating the valve connected to the plunger, pressure is being applied on the plunger. A valve which passes the pressure to the pressure gauge. By operating the valve connected to the pressure gauge, the flow of oil passing through the pressure gauge is controlled. And a set of dead weights. The weights are used to apply the load on the experimental setup. We have two weights weighing 1.4 kg each and 5 weights weighing 0.57 kg each. Let us start the experiment. Initially, you should make sure that the valve connecting to the plunger is completely open and the valve connecting to the pressure gauge is completely closed. Now, we start placing the loads one by one upon the plunger. Initially, you should place the 1.4 kg loads. You have to make sure that the groove on the load sits perfectly on the plunger and there is no play involved. Similarly, place the other loads one upon the other. Now start applying the pressure by reducing the area towards the plunger by rotating the plunger valve. Now you can notice that pressure has started building inside the equipment. Continue building the pressure until the plunger takes the maximum pressure and lifts up because of the load. Now we can see that for this particular load, a maximum pressure of 20 kg per centimeter square is being applied. Similarly, calculate the theoretically possible pressure using the formula pressure equals load by area and compare between the theoretical value and the measured value. Now we need to remove the load one by one and note down the corresponding reading being shown in the pressure gauge. Similarly, for each of the loads being removed, we need to calculate the theoretically possible pressure using the formula pressure equals load by area. We can observe that for every load being removed, there is a decrease in pressure being recorded in the pressure gauge. Before removing the last load, make sure that the pressure inside the setup is completely zero by opening the pressure gauge valve. Otherwise, the oil inside the setup will spurt out through the input valve. Now you can see that the pressure is reading zero and you can safely remove the last load. Now plot the graphs for the actual pressure versus the measured pressure and the actual pressure versus the percentage error observed in the equipment. This concludes the experiment calibration of pressure gauges using dead weights.
At MSR UAS, we spark your imagination unlike any other.